All right, we are looking at square roots and real numbers. And so, again, there's that real numbers thing. We're going to talk more about real numbers and non-real numbers today. So we're evaluating some different things with square roots, and we're classifying numbers based on what type of number they are. I mentioned earlier that we had talked about integers. We talked about more numbers besides integers, and today's the day. So first thing we're going to look at, squares. We've been looking at squares already, exponents. So we got 1 squared, 2 squared, 3 squared, 4 squared, all the way through 20 squared. And we're going to make a list of those. And so I'm going to have you write these down, and then we'll come back and we'll talk about them. So go ahead and write down the first 10 perfect squares, and then the next 10 perfect squares. I am going to expect you to know these. You can have the list out in front of you, but you will be expected to know all of these, either by memorizing or by having your notes handy. If you go ahead and pause it, write all these down. All right, now that you've written them down, the first 10, I'm assuming that many of you already know. 11 squared, 12 squared, many of you know those. A couple of quick hints for you in terms of ways to remember these. Grouping. 13 and 14 group really well together. 13 is 169, 14 is 196. So 13 squared, 169, 14 squared, 196. 15 squared, since 5 squared is 25, 15 squared, 225. 16 and 17, the way I remember 16 and 17 squared is it counts. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. So 16 squared, 256. 17 squared, 289. 5, 6, 7, 8, 9. 18 squared, again, the way I remember it is that 3 times 8 is 24. So 18 squared is 324. 19 squared, I have no nice way of remembering 19 squared. The only thing I can find with it is that it counts by threes a little bit. 1, 3, 6, 9. Not in any good order, though. So 361. However you want to remember that is great. And then the last one, 20 squared, is 400. And the 10, 20, 30, those are really nice because 10 squared is 100, 20 squared is 400, 30 squared is going to give us 900, 40 squared would be 1600, and so on. And so the 10s work really well. We have to know those either through memorization or by having this list out in front of you. What we're going to do with these is we're going to be looking at square roots. And so a number that's multiplied by itself to form a product is called a square root of that number. And so we've got that square root of that product. I'm actually going to do something here really quick, so we're going to go with that. Of that product. So the operations of squaring and finding the square root are inverse operations. Just like the opposite of plus is minus, the opposite of times is divide, the opposite or the inverse operation of square root. And so we can go back and forth between square and square root. Looking back here, if I have my list, that would mean then that the square root of 9 is 3. The square root of 4 is 2. The square root of 49 would be 7, because 7 times 7 is 49. Another way to look at that, and I've got this on your notes here that you'll be filling in, is that since 4 squared equals 16, 4 times 4 equals 16, the square root of 16 equals 4. And I apologize, I didn't unveil that. The square root of that product is what we're putting in that box. But since 4 times 4 is 16, the square root of 16 would equal 4. Now, where it gets a little bit trickier is that that's not the only answer. There's another number where something times itself equals 16. Could you think of it? Ends up being that negative 4 times negative 4 also equals 16. So negative 4 squared equals 16. And since negative 4 times negative 4 equals 16, the square root of 16 also equals negative 4. There are 2 answers. In fact, with square roots, you will almost always have 2 answers. One time you wouldn't would be 0, because there's no opposite to 0. So 3 times 3 equals 9. Square root of 9 is 3. But negative 3 times negative 3 is also 9. So the square root of 9 is also negative 3. since there are always going to be two answers, we're going to have write this down. It looks like it's already kind of there for you. Positive real numbers have two square roots. The square root of 16 is plus 4 or minus 4. And this new symbol here is our mathematical shortcut. Mathematicians are lazy. So rather than putting 4 and negative 4, we write this symbol here, plus or minus. The plus sign and the minus sign next to the 4. And that gives us the two answers. That essentially means 4 or negative 4. And so we've got plus or minus 4, which means 4 or negative 4. And that plus or minus sign is where we're going to write that. And with any real, any positive real number, it's going to have two square roots. Okay, so I'm going to have you try these 6. Find the square root of each of these numbers. Remember that you can use your list here of your squares and your square roots and say, well, okay, if the number is 49, square root of 49 is 7. If the number is 9, square root of 9 is 3, or negative 3. Square root of 49 is 7 or negative 7. So use your list to help you and try these problems. I'm going to assume you tried it. I'm really hoping that you got the first line. If you got the first line right, you've been paying attention, you've been and you're ready to go. The second line is a little bit harder, and we'll look at those too. So the first line, like I said, I'm really hoping you got these. Since 9 times 9 is 81, the square root of 81 is 9, plus or minus. Because positive 9 times positive 9 is 81, and negative 9 times negative 9 is 81. Square root of 324, again, 18 times 18 is 324, but so is negative 18 times negative 18, so plus or minus 18. 121, 11 times 11 is 121, but again, negative 11 times negative 11. So we've got plus or minus 9, plus or minus 18, plus or minus 11. For the bottom three here, I'm going to scroll down. We've got the square root of 25 over 49. That's kind of weird. Again, it's a fraction. But the way you can think about it is some fraction times itself equals 25/49. Now, I know that 5 times 5 is 25, and I know that 7 times 7 is 49, which means that the square root of 25/49 is going to be 5/7, plus or minus, because negative 5/7 times negative 5/7 would also be positive 25/49. So a fraction, you still take the square root the same way. You just take the square root of the numerator, take the square root of the denominator, and you've got your fraction. And this is why it works, because 5/7 times 5/7 is going to give you 25/49. For the next one, the negative. If the negative's out front, we can kind of ignore the negative for a little bit and look at that square root of 9. So the square root of 9, the square root of 9 is, well, 3 times 3 is 9, plus or minus. Now we've got that negative there. All right, so let's take a look. Negative plus or minus 3. That's kind of weird. But let's look at what's actually going on. If you take negative is the opposite. Negative 3 is opposite of 3. Negative 8 is opposite of 8. And so the opposite of positive 3, negative 3. The opposite of negative 3, positive 3. So really, when that negative is out front, nothing really happens. It doesn't affect anything. Since we have plus or minus 3 to begin with, that negative just reverses them, which really doesn't mean anything. If there's a negative sign in front of the square root, like in this problem right here, if there's a negative sign in front of the square root, nothing happens. You still have the same result of plus or minus 3. And that is retained. For the last one here, the square root of negative 16. So now you have to think, what's a number that when you multiply it by itself, when you square it, you get negative 16? Well, 4 times 4 is 16, but negative 4 times negative 4 is also 16. You can't say 4 times negative 4 because those are different numbers. It's got to be some number times itself. In fact, there is no real number that you can multiply by itself and get negative 16. It's not that there isn't an answer. It's just not a real number. So our answer is going to be no real number. And this is where we kind of dabble in unreal numbers in that we acknowledge they're there. We acknowledge they exist, but we don't write the answer for them. We're just going to say there's no real number for this solution. There's an unreal number, which again I'll talk about actually in just a little bit, but there's no real number. So if there's a negative inside the square root, we can't do it with real numbers. So it's no real number. If the negative is outside the square root, no problems. We just write it as if it wasn't there. I don't know why that happens, but weird. Okay, so no real number. Okay, moving on. You don't need to write this down, but it's already written there, so you can take a look, read through it quickly. If we have a number that is not on our list, so I'm going to go back to our list here. If we have a number that is not on this list that we have of our first 20, or really any perfect square list, then we still need to be able to deal with it. It's not that those numbers aren't there. You can take the square root of 5, even though 5 is not in here anywhere. 5 isn't on our list of perfect squares. We don't have it on our list. We can still find an answer. And so square roots like the square root of 15, we don't really have a nice number for. In fact, your calculator can't give you an exact answer either. It's a number that never stops and never repeats. It's a lot like pi. Pi is what's called an irrational number. And that's what we call numbers like square root of 15. Square root of 15 is an irrational number. It doesn't really make any sense. And so an irrational number is a number that we can't take the square root and get a nice number. No, your calculator can't. It can approximate, it can round to 10 places or 12 places or 20 places, but it doesn't really know what the answer is. Nobody does. And so if it's not a nice number, we don't know what it is, but we can guesstimate. So I'm going to have you write this down. Square root of 10. Square root of 10. If I look at my list, I'm going to go back here, I'm going to look at my list. 10 is not on my list. I've got 1, I've got 4, and I've got 9. But I do not have, oh, and then I've got 16. But I don't have 10. So 10 is somewhere in between 9 and 16. Somewhere. It's not halfway between, but it's pretty close to 9. So it'd be right about, I don't know, here. 10. Right? Which means it's pretty the square root of 10 then will be pretty close to 3. And I'm saying that, but I'm hoping that you understand what I'm saying, but we'll try it again here. Since 10 is close to 9, the square root of 10 would have to be pretty close to 3, somewhere between 3 and 4. Since 10 is in between 9 and 16, the square root of 10 would have to be somewhere in between 3 and 4. And so we're going to guesstimate. And we're going to say that the square root of 10 is about, and we're going to use that symbol there to say it's about, I don't know, 3.1. Now, you can check it, I know, with the calculator on a test or a quiz. What I would expect from you is I would expect you to get within 2 decimal points. And so if I look at the actual square root of 10, I get 3.16. And so I guesstimated 3.1. The best answer for rounding would be 3.2. That would be the best answer. Since 3.2 is the best answer, I would give you on a test or a quiz 3.1, I'd give you full points for, 3.2, 3.3, or 3.4. Anything above that, anything outside of a 2-point range, you're too far off. You're estimating way too far off. Because if I look at my list, I know that 10 is not halfway between 9 and 16. So I know that the square root of 10 will not be halfway between 3 and 4. So 3.5 is going to be too big. It's got to be somewhere lower than that. So I'll give you a little bit of leeway with your guesstimating. And in fact, I was a little bit off as well. But if you said 3.1, 3.2, 3.3, 3.4, I'd give you those points. So try these 3, see what you can make of it. Okay, here we go. So square root of 300. Again, 300 is not on our list but we can estimate, we can guesstimate, we can zestimate, whatever you want to call it. 300 is somewhere in between 17 and 18. It's somewhere between 289 and 324. And if we look, it's actually not too far away from halfway. It's a little bit closer to 289 than it is to 324. So it might be a little bit lower than 17. So if I were going to make a guesstimation, I would say it's about 17.4. And we'll check the actual or the best answer in a minute here. 156, same thing. So I'm going to go back. I'm going to check with my list. 156, and we're looking at somewhere in between 144 and 169. So 156, well, that might be, that's about maybe what, halfway? About that. So if we said, and what was that? That was between 14 and 15, so 14.5. Again, we get a little bit of leeway with that. And 18, the square root of 18 is not 9, remember, because 9 times 9 is 81. The square root of 18 would be somewhere in between 16 and 25. It's going to be closer to 4 than it is going to be to 5. And so we'll say maybe 4.2. And if we check, those results to see how close we actually are, we're looking at, 300? We're looking at 17.3. Is going to be the best answer for this one, 17.3. So you can tell that I'm doing this along with you. I'm not using the correct answer, but I'm getting close. We got 156. We take the square root. We got 12. Oh, I'm sorry. I said 14.5. I apologize. I meant 12.5. 12.5. And so if we look at my list, then we've got, it's 12.5 actually. That is the best answer for that one, is 12.5. For number 18, and so for square root of 18, I had said 4.2. The best answer is actually 4.2. And so 4.2 would be the best answer for that one. But I would give you 2 decimal points on either side. We're going to stop here. There is more, but we'll have to do it in another video because we're getting a little bit too long.